All right, we've moved into rebuilding the small office network part 3. And without any further delay, I'm going to pick up right where we left off, which was routing protocols. Let's just take a moment to get back up to speed with where we left off. In the previous video, we set up the foundation configuration in all these routers. The names, the passwords, the IP addresses, and the work environment that we were going to be working in for the rest of the series. And now we've got a point to where all of the routers have IP addresses, but they can't really reach anything. Well, I shouldn't say that. They can only reach what they're directly connected to. Since we don't have routing turned on, the routers are able to ping local interfaces because that's all they know about. So what we need to do is enable a routing protocol, or static routes, a bunch of them, or let's just use a routing protocol, RIP in this example, to get these routers to tell each other about what they know. Now we're going to set up RIP and use RIP in our initial configurations, and later on we're going to pull RIP out and put in some other routing protocols and see their advantages. Now you also see I've got the internet IP address up here. This is ours, and this is the ISP that we're going to be routing to get off to the internet. But I want to hold off on doing that until we set up RIP, and I'll show you why once we get there. So let's start off on router 1. To set up RIP, what I'm going to do is first off well, I've got my aliases now, right? So S is for show IP interface brief. Get a view of the interfaces so I know exactly what network commands to type in. Now I'll also type in show IP protocols just to make sure there's no routing protocols running. It's blank, that's good. So we'll get into global configuration mode, and I'll turn on RIP by typing in router RIP. Now that enables RIP. It's like a light switch. I just turned on the RIP routing protocol, but I turned it on in version 1. Now version 1 came out. The engine was developed in the late 60s. I'm not kidding. The 1960s was when the RIP engine was developed that we're running right now. And we don't want to use that. We want to use version 2, which came out in around the 80s, which enhanced a lot of the features. It made it classless, so we could handle different subnet masks. It added authentication, where we could have passwords between our routers, that sort of thing. So I want to turn on version 2 on all the different devices. Now comes the big command, network. We type in network, followed by what network we would like to run RIP on. Well, this command does two major things, and these are the two big ones I want to talk about. When I type in network, I'm going to follow it up with, well, let me type it in as I say it, 192.168.1.0. What that does is tell RIP to advertise this network to all of its neighbors. So when RIP starts forming neighbors, router 1 is going to send out advertisements saying, hello, I know about 192.168.1.0. I know about this whole network. And that's great because that is going to be the network that we're advertising that we are able to reach. Now, for router 2, that's not going to be too much information because it's going to think, oh, well, I'm connected to it, so I already know about that. I do not want to advertise this network, the public network, because I don't want any public routes going into my internal system. We're using private addressing inside of this company. And if we start advertising public routes all throughout the system, it can be a bad system for security. And again, I'll explain more of that as we get deeper into the routing protocols. I only want these routers to know about their private networks. So for router 1, I'm done. Before I go on to router 2, let me mention that was the first thing the network command does, is advertise that network to everybody else. The second thing that it does is choose what interfaces to send advertisements out of. Now again, bad English, but I think you get the point. When I type in network 192.168.1.0, that tells RIP send hello mess or send advertisements, updates out Ethernet 0/0 because it starts with 192.168.1. something. It's not going to send advertisements out this interface because it doesn't start with 192.168.1. something. Now, final thing, remember in RIP, and I know we're using Class C addressing here, so it's not going to be as obvious, but remember in RIP, it is still in its configuration class full. So for example, if I had 10.1.2 network over there to the left, I would advertise it into RIP by typing in network 10.0.0.0 because by default, 10 is a Class A address. So there's my cram session on RIP. So now that it's configured on router 1, I can jump back and do a show IP protocols, the same command I typed right here and return nothing. To find out that RIP is running, sending updates, broadcast once every 30 seconds. The next one is due in 8 seconds. So if we start the countdown, it's going to send another broadcast. Now notice down here, it doesn't see any other routing information sources. That's because no other routers are running RIP. Once we get router 2 running, we should see router 2 as a source of information. We also see the networks it's running on and the Ethernet it's sending the interface that it's sending advertisements out of. Good. So let's save that config, hop over here to router 2. I'm going to go into global config mode. Let's do that show IP interface brief command. Notice I did do space S to execute a show command from global config mode. And I can see that I've got fast Ethernet 00 and serial 0/1/0. That are my valid interfaces. That'll be valuable when I type in router RIP. I'll do version 2, get version 2 running, and network 192.168.1.0. That will allow it to advertise and talk to router 1. And then I'll type in a network 192.168.2.0, which allows it to advertise and communicate out the WAN link. So at this point, I should be able to jump back here and do a show IP protocols on router 2 and see that we're running RIP. We're advertising for 192.168.1 and 2.0 out these interfaces. It hasn't heard from router 1 yet because it waits 30 seconds before it sends the updates. Router 1 is. So I'm sure if we hit the up arrow a few times, give it 30 seconds, we'll actually see that. Let's hop back over to router 1. Do a show IP protocols, and you can see there it is. Router 1 has seen router 2 now as one of its sources. So I should be able to do a show IP route now on router 1 and see one of these networks that have been learned by RIP. Now remember, it only knows about connected interfaces out of the box. So by running RIP, we've now learned about 192.168.2.0. So at this point, I should be able to ping. Well, let's ping everything. Let's ping router 2. Ping 192.168.1.2. That's router 2's IP address. Of course, we should be able to ping that. How about its serial 0/1/0 over here? 192.168.2.1. 2.1. Sure enough, we're successful because it knows about that RIP route. It can reach that network through this next hop IP address. Now let's try and ping router 3 over here, 192.168.2.0, 2.2. It knows about the 2.0 network, right? So that should work, right? Not so. The reason that it's failing, and this is a big void in a lot of people's minds when they're doing routing, you have to remember routing is always a two-way street. It's a two-way process. When router 1 is pinging router 3, it's actually sending the packets because it knows how to reach that network. It's coming down here, and remember the source address is 192.168.1.1. It hits router 2 because that's the next hop IP address. Router 2 knows how to get to router 3, so it forwards the packet down over here to router 3. And if we were able to put a packet sniffer on the line, we would actually see the ping requests coming from router 1 and being received by router 3. The problem is it's coming from a source IP address of 192.168.1.1. And router 3 does not know about the 192.168.1 network yet. So when it's getting those, it's looking at its routing table for the return path to send a reply back, and it's saying, I don't know how to get there. The routers aren't smart enough to say, well, I saw it come in this interface, so I'll just go back out that interface. They rely on the routing table for everything. So in order to allow those pings to be successful to router 3 right here, we've got to set up RIP over there. So let's hop over to router 3. I'll do a show IP interface brief. Not used to my aliases yet. I'll go into router RIP version 2 network 192.168.2.0 and 3.0. So it will both send advertisements out of and advertise these networks. So with that in place, let's see if it's happened yet. It may take a moment. Oh, wow, that was fast. Router 3 has now learned about 192.168.1.0. So if I go back to router 1, notice all I did was set up RIP. Go back to router 1 and try that ping command again. Success. We are there. Because router 3 now knows how to get back. We should be able to successfully ping between everything. 3.1, that's the Ethernet interface of router 3. Matter of fact, let's go one step further. Let's do a trace route, 192.168.3.1. Enter. See right there, we went through router 2, and then we were able to reach router 3. Now you can see when you ping, or when you do a trace route, it does 3 separate pings to each hop. For some reason, and it's actually technically described on Cisco's website if you're interested enough, it will always drop the second ping of the final hop using a trace route. I can't remember why that is, but that's the fact. So don't ever worry about losing the second ping on the final hop. That's just a known issue, if you will. So at this point, I'm going to hop around and save my config on all 3 of those routers, just doing the right command. Also remembering that the CCNA approved method is copy run start, but write is much easier. So we now have RIP configured. I would say we're halfway there, half a check on this step. Now the next step is the default route. Let me just clear off all these scribbles right here and give us a clean slate. All right. We are going to now move into this Ethernet 0/1 interface up here and get it configured, and then we'll set up a default route to the internet. So, move over to router 1. Show IP interface brief. There's our Ethernet 0/1. It's currently shut down. So let's go into global config mode, interface Ethernet 0/1. And let me just, how about I scrunch this down a little bit? There we go. So we can see what's going on. I'm going to do the IP address 68.110.171.98. Now it's a /27 mask, so that will be, convert that to decimal, 255.255.255.224. Enter. Got that up. Sorry, I'm moving my window around as we go just so I can get my best possible view there. So did I do a no shut? If not, there we go. So we've got the address that is set, subnet mask. I didn't do a no shut. So the interface has now come up. And let's do a ping, 68.110.171.97, which is our ISP. Hit enter, and there we go. We've got the successful ping that is now going through. We're able to reach the internet. Now, with that in place, we have an internet connection, but we don't have any route to the internet. Meaning, if I were to ping some internet host, I always like pinging 4.2.2.2. That's a public DNS server. It's maintained by a university. It's the easiest address to remember in the world. Great way to test internet access. So if I try and ping them, and I know that they allow pings, it is failing. And the reason why is because if I do a show IP route, the only thing that this router knows about is the RIP routes that it's learned about from inside our organization and the connected interface to the ISP. It doesn't know about the internet routes beyond the ISP. Now, there's no way RIP is going to be able to manage that size routing table. So what most organizations use, and what we'll use in here, is a static default route. We do that by typing in IP route, all zeros for the IP address, all zeros for the subnet mask, and then our ISP's address. So I'll just copy this, save myself some typing, and put 97 in there. So that says to this router, send everything that you don't know about over to the ISP. And you can see automatically the routing table shows gateway of last resort is 68.110.171.97. We also see the static route tagged with a little star, which means it is the candidate default route. So that is the default route for everything. Let's try pinging 4.2.2.2 again. I hit enter. Glorious. We now have successful pings over to the DNS server. We're able to ping the internet. So our internet access is now up. Well, at least it is from router 1. Because remember, all of the other routers in our organization can get to the internet, but they're coming from private addresses. As soon as they reach the ISP, they're going to be blocked because private addresses are not allowed. That's why we have NAT, which is going to allow us to translate all of those addresses before they go. Now, I'm not going to do NAT at this point because that will be something that we do later on via the command line. So with the last piece in place, what I want to do is verify and back up our configuration. I want to use the Cisco Discovery Protocol, just like we did on the switch, to verify our connections. TFTP, that's where we can set it up. I've got this host right here as the TFTP server, 1.50, and we'll copy some of our configurations over there. Do show IP routes, interfaces, just verify that everything looks good. I'm going to start back on router 1 because there's still one ultra cool thing I want to show you. Router 1 has the default route to the internet, right? It knows how to get to the internet. The other routers are not able to reach the internet for two reasons. One was the NAT reason I just discussed, but number two is they don't have a default route. I would have to go on router 2 and do the IP route 0000, point it to router 1 to say, send everything you don't know about router 2 to router 1, and I'd have to do the same thing on router 3. That's known as putting in a default route. Now, NAT would be the second piece of that to allow them to reach the internet. What I want to show you is a feature that Cisco has that is very cool. It can be done for just about any routing protocol. And what I can do is go into, in this case, we're using RIP, router RIP, and type in the command redistribute static. Now, just by looking at that command, it should, in your mind, trigger, okay, I'm going to redistribute, I'm going to send some static routes into the RIP process. Now, if I do a show IP route, the only static route that we have is that default route, so I'm advertising that route into RIP. So what it's done is kept me from having to go to all these other routers and give them a default route. Let me show you. I'll hop on over to router 2 and do a show IP route. And look at this, a default route learned via RIP, it's not a static route anymore, that automatically adjusts itself. Send everything to 192.168.1.1, which is router 1 in that picture. If I were to hop over to router 3, show IP route, I can see that this one has a default route as well, sending everything to router 2. So that will save you a lot of work of having to type in static routes or default routes on every router in your organization. Now, I should also mention at this point that is something that is not truly discussed until you get to the CCNP video series. So that's bonus info. It's good stuff. So we've got verify and backup. I'm sitting on router 1. Let's do a show CDP neighbors just to verify our connections. And I can see that I have two connections to CBT switch 2. I'm actually using the same switch to reach the internet, going through the internet from that switch, and that same switch is connecting me to the LAN. So I'm able to verify my connections there. And I am going to now back up my configuration on router 1. Now, TFTP, this was something that we didn't do in the initial video. I just backed up my configuration through Notepad because TFTP is useful for backing a bunch of configurations up to a centralized server. First things first, TFTP server of choice, this one right here. TFTP D32 by, I think it's Phil Jonin. Just do a Google search for TFTP D32. It's free. You can download it, install it on Windows, and it is a great TFTP server platform. So, just by installing this on Windows, double-clicking the icon, poof, my local 192.168.1.50, this guy right here, has become a TFTP server. So if I jump on over to my router 1, let's make sure that I can ping before I do the copy. 192.168.1.50. We are able to ping it. I can type in copy running config to TFTP. Enter. What is the address of the host? That's 1.50. What do you want to name that file when you copy it over? By default, it's going to name it r1config. I'll actually keep that name, but I'll put r1config.text. And actually, before I do anything, I'm going to change my directory that is the TFTP is pointing to a folder on my desktop called TFTP. Otherwise, it just throws files all over my desktop. So I've got TFTP as my destination folder. That's what I'll name it. Enter. And not much action happened there. I can look at the log, and you can see that it received a file from that host and received the right request for that. Good. So now I'm able to go over to router 2. Always ping the host before you try and TFTP so it doesn't hang there forever if it can't reach it. Good. Copy running config TFTP. I'll actually show you another way you can do it. I could say TFTP : / 192.168.150 / we'll do R2 C, what did I name it up there? Config.text. Enter, and it'll automatically have all these things filled in for me. So that's a matter of preference. If you like doing the URL style or just letting it walk through the wizard, you can do either or. So I hit enter, See if I can pop this up in time. Oh, we saw it flash. These running configs are very small, so you don't see too much copy time. And then finally, let's go over to router 3. Since we have RIP set up, router 3 should be able to reach over here to this LAN and be able to get its config over. So let's do a copy running config. Oh, wait a sec. I almost broke my own rule. Let's first ping the TFTP server, make sure we're able to reach it. Sure enough. Now we'll do a, see, cut and paste is so great. Copy running config to TFTP. We'll name it router 3. Enter, enter, enter. And poof, success. We have now copied that over. Now if let's see if I can find it. All right, I'm going to display my desktop, which is an empty black hole. Where's that TFTP folder? There it is. Right there. TFTP, and bring it up. There is all of the configuration files that I've now copied over. It looks like I copied router 2 config at some point, but config without the I, all 3 of them. If I double click, it opens in Notepad, which is brutal because Notepad does not understand return characters. So everything's all on one line here. Nice. So what I prefer to do if you're using Windows is open with WordPad, where it will format it much better. So that is creating a true backup of all the configurations of our routers. Now, one last thing I'd like to do, and that is back up our iOS. Let me just get my network diagram back in place. There we go. My term, good. I want to back up a copy of the iOS just so that we can review how to do that. I'm sitting on router 1. I'm going to do a show flash because the iOS is stored in flash. This is a 2600 router. I can see the iOS file name right there. So I can type copy flash TFTP. Let the wizard guide me. This is one you definitely want copy and paste for because this is so prone to mistypes. So I just copy that name in there. That's the source. The address of the TFTP server, still 192.168.50. It will keep the same file name as the destination. I hit enter, and now you can see it's copying that iOS version over. If I grab my TFTP server, jump over here, you can see that it is receiving that file from that host. So that is our way that we can back up our iOS, and also how we upgrade our iOS. We could just reverse this command and type copy TFTP flash to copy the iOS from the TFTP server into flash. So this is a great way to review rebuilding that small office network. Let me get back to my objective slide here. I'm hoping that acted as a great dive in with both feet sort of review to lay that network foundation before we get into the new stuff. Everything from here on out will be building on top of this infrastructure. It's going to kind of add the features that we're looking for to enhance and grow this network into, instead of a small office network, move into a medium, large, even you could say enterprise class. Some of the enterprise style features will be talked about as we go throughout this series. So in these last 2 videos, we walked through a review of key router concepts, things like routing protocols, static routes, assigning IP addresses, base configurations, and we did a review of the key configurations. That's all we did, was walk through a complete setup of a small office network. I hope this has been informative for you, and I'd like to thank you for viewing.